Hi everyone, today we're going to study variance of random variable x. In a statistical point of view, expected values are used for understanding of random variable. Sometimes it is observed that expected values are exactly same for two different probability distributions. In such situation, it is difficult to compare the two different situations. In this case, standard deviation is the most appropriate statistics that is calculated by obtaining the variation in the random variable. This type of challenge is resolved by calculating average risk variability that is not unique using variance. Variance alerts about the variation in the data. Let us study now variance and standard deviation. If a random variable x have a finite mean or average, and we use the symbol mu, then variance of x is defined as rho square. This rho square is the variance equals e of the square of the quantity capital X minus mu. Now the standard deviation of x, this x is the random variable, is the rho, and this rho is equal to the square root of the variance of x. In symbol, we show this square root and the variance of x. Also, using the formula of the variance here, the standard deviation is now the square root of this quantity, which is the e of the square of the quantity capital X minus the mu. Now let us see some properties of variance. Number one, the variance of k times x. This is equal to k squared times the variance of x for all real number k. Second, the variance of the quantity x plus k equals the variance of x for all real number k. Third, the variance of x is greater or equal to 0. And this is equal to 0 if the p of the quantity x equals k equals 1 for all real constant k. Fourth, the variance of x equals the e of x squared minus mu squared. Remember this formula. This is the formula that we're going to use later in the next video to solve for the variance. This formula is also known as second moment, where x is the random variable. We shall have some sample problems in the next video. I hope you learned something from this video. See you again next time.